Okay, the next presentation focuses on something that we've had a lot of in the run-up to the show, which is the clenching of jaws, the grinding of teeth, hopefully not the sleep apnea bit. Our next two presenters are Nicholas Dill from EOS and Elias Dürr from the Orthos Dental Laboratory. They'll be talking about developing an additively manufactured solution which really focuses on some of the core benefits of additive manufacturing, which is getting parts made quickly and, of course, customizability. And these medical and dental applications are really the highlight of that because we are all different and therefore each part needs to be different. So they will be talking about an innovative nylon occlusal splint and a unique mandibular advancement device. So, gentlemen, over to you.
Thank you for the introduction, and thank you very much for having us. Who of you enjoys a good night's sleep? Who of you enjoys a sleep that's not disrupted? So we wake up in the middle of the night, etc. Last question, who of you snores? So you don't have to raise your hand. I do sometimes, I can admit that. And the good thing is, we're not alone. So with me today, there's Elias from Orthos and myself from EOS, and we'll guide you through how snoring and sleep apnea, two widely and common conditions, can be tackled. Less than 50% of people have an open airway. They do not snore. They have a, let's say, not a sleep disruption due to physical reasons. There may be others. And then a large share of people suffer from disrupted sleep. So you have a partially blocked airway, which happens to a lot of people, roughly 57%. And then there's also, on top of that, obstructive sleep apnea, where you have a full blocked airway and can actually occur that you wake up 60 times in an hour just because your airway is blocked. And that can actually lead to severe health challenges, not only being kicked at night and sleeping on the couch, but also actual health challenges. So the risk of heart attack increases, the risk of stroke can increase, particularly if you grow older. They're correlated. In countries where obesity is a problem, this actually grows a lot too. And it's a very, very common condition. However, the conventional treatments and the conventional solutions are not always perfect. So I'm very happy to have Elias with me on stage. What is it that, let's say, is challenging in today's sleep apnea treatments?
The sleep apnea treatments, the mostly common treatments are the masks, like CAPA masks. You have a mask over your mouth and your nose, or just your mouth, and it creates a continuous air pressure into your airways, into your lungs. And the problem here is that our devices are linked to a machine, and the machine could be loud, the machine makes noises, and often the masks are very uncomfortable. The masks have to be linked with this machine, so you have a tube or some kind like a hose which is connected to the machine, and to place it into your bed or next to your bed, that it isn't disturbing your sleep, it's very tricky. So there are some cases of like an arm over your bed where you can hang it, but yeah, that's not the perfect solution for this. And of course it requires electricity, so if you're on tour or camping or something like that, you need permanent electricity to run the machine.
So you have two things: either you have a loud snoring partner or someone snoring, or you have a super loud machine. And that leads, as you said in our preparation, to one thing, that people do not go through with therapy. So they stop the process of treating their sleep apnea.
The problem why this abandon rate is very high is that, as I said, the mask is a discomfort while sleeping. Then you have often the problem that the air isn't just going into your lungs, it is also going into your stomach and causes bad effects. And the last thing is the airway dryness. If you have a continuous airflow through your airways, it's drying out and you can't rehydrate it with saliva or something like that because you have this mask on. Yeah, that's a problem. That's why they break up the therapy.
Thanks for sharing. And now, luckily, you've been working on creating a new solution. You've developed a product that can tackle all of these challenges. How did you, let's say, get to the solution, and what does it improve for the patients?
Yeah, our product is a splint in both jaws, which holds the lower jaw forward, so that the tongue and the muscle you have in the throat can't do pressure on your airways and block them. So we have 2 appliances for that. It's the Lunasol and the Lunasol Duo. The difference between them is just the indication if the patient has, for example, prosthesis, as in the presentation before, then you can use this one. And for the other patient, we have the standard Lunasol. It is fully customized, so the whole process is digitally, and this process chain can make our precision fitting very safe, and it is an enhanced comfort in comparison to the masks. So it's very thin, and it's strong, durable, and if you wear it, you don't really feel as a discomfort when you're wearing it. And the biggest part, which is the reason why our German health insurance system is taking a lot of the costs, is that it's dentist and specialist approved. So we get our plans from the dentist. Yeah.
And you mentioned it improves comfort, so I could imagine, I mean, you don't have the pressure on your face any longer, but still putting a piece of plastic in your mouth, how does it feel? Is that a big change, or?
It's not a big change. The first evening, of course, it's new and you feel it, but if you wear it the first night, you have the positive effect the next day, so it feels good. Yeah.
Excellent. Elias can actually build on his experience, so it actually is comfortable. And to understand, you mentioned digital process chain, so you need a digital file, right, from the dentist or an intraoral scan. Someone creates the data at the patient. How do you come from data to the final product then?
First of all, we need the data of the patient, so we work with scans or with models or impressions, so we can scan them by ourselves, get it into our program and our process. So every single of these devices are individually designed, and we are looking for the perfect position of these appliances, and that works very good. After that, we have an STL file which goes into our production line, and we are printing with the EOS Formiga. And after the print, we are sandblasting the parts, we are tumbling them, and the last step is a smoothing, a vapor smooth system. Yeah. And after that, we have a control system, because every patient is individual, and so every splint has to be individual. That's the reason why we test everyone on the model, and after that it goes to the dentist.
And what happens now? Let's say you mentioned you've been wearing the device for 2 to 3 years now. It lasts quite a long time. What happens, let's say, after 3 years? I don't know. I lose my device on a plane or on a train.
If this happens, it's not a big deal, because we have already the data. So the process chain is so safe that we can get the same device after it if we print it new. So that's not a problem. We are printing it again. Yeah.
And how long does it take from, let's say, scan to delivery?
It depends a bit on our product times, but normally 10 to 14 days, I would say.
Okay.
Yeah.
Yeah. Great.
We are printing it in Germany, so for the DACH region, I would say it's very quick. Yeah.
Yeah. And we talked about it before, so you also apply a similar process chain to a different solution. So teeth grinding is a topic. People are stressed out. You communicate on several channels, whether it's Teams, mail, etc. Particularly in preparation for Formnext, at least for myself, a lot of stress. And that leads to tense jaw muscles, right? You have back pains, neck pains, and can impact your sleep as well, and inflammation of the jaw and its joints. And luckily, with a similar process chain, you can also create a similar medical device to treat this problem as well. Can you elaborate on that too?
Yeah, of course. That's the first thing we printed on our SLS machine, on the EOS, because almost every dentist is given a few splints per week to patients. So yeah, the asking for them is very high, and normally they are a bit they are not that flexible, so they can break, or yeah, it causes a lot of problems because there are many reparations because of the material. So when we invited the PA, it leads to a very safe process, and yeah, it's also fully customized, and the extremely thin and flexible design, as I told before, is here yeah, same usable, the usability, and the biggest point why we can use this is the biocompatible and extremely robust material.
Thank you. And I think one thing we also mentioned in preparations is that you can now down to 0.6 millimeters in wall thickness.
Yep.
So really trying to reduce the feeling in the mouth that you have, let's say, a very comfortable, very light and durable device.
Yeah, the parts actually are you can feel with your tongue are very thin, so you don't even realize you have something on your teeth. Yeah.
Last but not least, of course, as we're coming from EOS, and a question that we would have: how did you, let's say, explore additive, and how come that you eventually chose SLS and a thermoplast nylon for your solution?
Yeah, we were increasing our company, and we had a lot of splints that we were milling or we were producing them in other thermoplastic processes, but we need a safe and a strict process which we can where we can produce medical grades and these splints in a very good quality. So yeah, we were searching for a new printer, for new material, and yeah, the EOS was perfect fitting for that. Yeah.
Yeah, so to quickly extend on that, I think dimensional accuracy is a key topic we always work on, having high repeatability across the build job. At the same time, thin walls can both be built on a P3 and a P1 as well.
Yeah.
And then you shared a lot on that the material is a key component, right? Breaks less, has a very, let's say, attractive overall property profile. Thin walls can be built, but also ductility, as well as, let's say, compliance with all the medical grade regulations. Yeah, I think coming to a close, we are very proud to have you as a partner helping people sleep better.
Thank you.
And let's say for you out there looking to either look at sleep apnea or looking at reducing your teeth grinding at night, we've also added, not as big as the previous presentation, smaller QR code where Orthos can share where all the dentists that they work with are attached to. So we invite you to test out the solution if you have someone that is actually in need of a, let's say, sleep apnea device or snores at night, you want to save their relationship, or maybe also grinds their teeth and stress of preparations for Christmas and whatever occasion. And with that, thank you very much for sharing more on the application. And I think we have 5 minutes for some additional questions.
We do. I will come around with the microphone.
Yeah, great. So I just wanted to know more on your scanning. Are you doing the teeth scanning or the mold scanning?
The scanning of the mouth, or
Yeah.
it works with several systems. So there are many companies which are producing intraoral scans, and they work very well. So that's our most most precise process, and the splints fit very well. Yeah.
And
But
the
it-
material you said is PA 2200.
Yeah.
So can you give a little more on that material? I mean, specific to a machine or?
So the material is, let's say, our most common material for medical appliances. It's, let's say, a nylon 12. It's biocompatible. It complies with ISO 10993. And within, let's say, our in-house lab, it's extensively tested. So every batch, you get a material batch certification. It's been out there in the market for a very long time, 2 decades, a little more. So it's tested. It runs on all of our systems. So it's very versatile and flexible.
Where we can get more information on the scanning?
The scanning is very individual. So if you get plaster models, we're scanning it by ourselves with desktop scanners. They are, I would say, in this size. When we get impressions, we have to make a model first out of plaster and then scanning it. But if we get the scans from the dentist, it's the direct way, because we haven't created a model before we are creating the splints. I would say the rate of the intraoral scans is increasing. I would say 60 or 70% are scans we get. Yeah.
So I think to add on to that, you can do both, right? You can do the plaster molds, which can then be scanned in the laboratory, or you have the intraoral scan. So both feeds into the solution.
Yeah.
Okay, thank you. Time for one last question if anybody has one. If not, you can scan the QR code, and the EOS booth is very handily located, I believe,
Not so far.
just down this aisle here.
Yeah.
So for this application and more, you can visit there. Gentlemen, thank you very much.
Thank you.
Thank you.
Yeah.